Good morning, students. This is the 8th video. Uh, we already discussed the pre-expansion expression for W and expression for U and Q, internal energy and heat. Today we have to discuss about expression for delta H, enthalpy. Expression for enthalpy. Expression same way, same formula, same outcome, whatever it is in the reversible process and irreversible process, same formula also we get in case of free expansion. But we do it. In the initial state, what happens? Enthalpy is H1 is equal to U1 plus PV1. Pressure is constant. This is the initial state. Final state is H2 is equal to U2 plus PV2. This is the final state. This is the initial state. This is the final state. Final state. This is the initial state. This is the final state. Then what is the change in enthalpy? Now H2 minus H1, final minus initial, we get what? Now H2 minus H1 is equal to U2 minus U1 plus PV2 minus PV1. That means I can write delta H is equal to delta U plus PV2 minus PV1. And delta U, we already found that what is the value of delta U is minus whatever the value you get any delta U minus n rho square A minus n rho square A bracket 1 by V2 minus 1 by V1. 1 by V2 minus 1 by V1. Already we know this one. Delta U is this much. That means this thing I already know. Then next we have to find out PV2, PV1. Then we derive pressure from the Van der Waals equation. So we have to write Van der Waals equation first. P plus N square A by V square V minus NB is equal to nRT. Then take this one to this side. P plus N square A by V square is equal to nRT divided by V minus NB. Take this one to this side. P is equal to nRT divided by V minus NB minus N square A by V square. Then what is PV? Now you multiply V on both sides, left and right, we get nRTV divided by V minus NB minus N square A by V. 1 V multiply with V means 1 V will cancel. Then we need what? PV2. So what is the PV2? Now PV2 is equal to, in place of V, I write PV2. PV2 is equal to nRT V2 divided by V2 minus NB minus N square A by V2. Then what is PV1? In place of V I write PV1 nRT V1 divided by V1 minus NB minus N square A by V1. So we get PV2, we get PV1, we get delta U. Now put these three value in this equation. Now your delta H is equal to delta U. I put this value minus N square A 1 by V2 minus 1 by V1. This is equal to delta U plus PV2, this one, nRT V2 divided by V2 minus NB minus N square A by V2. PV2 minus PV1, this one minus nRT V1 divided by V1 minus NB, minus minus plus, we get N square A by V1. Now what you do, now make these two from these two, this one, take nRT common, and from this one to this one, N square A common. Then what you get? Now your delta H is equal to minus N square A 1 by V2 minus 1 by V1 from this and this, these two. Take nRT common. nRT common, you get V2 divided V2 minus NB minus V1 divided V1 minus NB. Then minus N square A you take common. When minus N square A common, this is 1 by V2, this is 1 minus 1 by V1. Okay, 1 by V1 minus N square A. Minus N square A or multiply minus N square A by V2 minus plus N square A V1. Now you see, this one and this one both are same. So what you do? Now you add these two. We get what? Now delta H is equal to minus 2N square A whole of 1 by V2 minus 1 by V1. Then plus nRT here V2 minus NB plus NB. We add and subtract, we subtract and add, that means cancel. V2 minus NB, no problem. Then minus V1 minus NB plus NB divided by V1 minus NB. Okay, now you make these two, V2 minus NB, V2 minus NB, NB by V2 minus NB. We get delta H is equal to minus 2N square A 1 by V2 minus 1 by V1. nRT you take common, then I make bracket like this, square bracket, then we separate this one, V2 minus NB divided by V2 minus NB, make it bracket, plus NB divided by V2 minus NB, then minus V1 minus NB divided by V1 minus NB. Then here is minus will plus NB divided by V1 minus NB, bracket N. This one cancel, this one cancel. So your delta H becomes minus 2N square A 1 by V2 minus 1 by V1 plus nRT whole bracket. This will cancel 1 plus NB divided by V2 minus NB. This one cancel, minus 1 minus NB divided by V1 minus NB. Okay, this plus 1 minus 1 cancel. So take NB common from these two. We get delta H minus 2N square A 1 by V2 minus 1 by V1 plus nRT. Take NB common. We get NB 1 by V2 minus NB minus 1 by V1 minus NB. Now this n square, n into n square RTB, then it is over. Delta H is equal to minus 2n square A 1 by V2 minus 1 by V1 plus n square RTB 1 by V2 minus NB minus 1 by V1 minus NB. So this is the mathematical expression for delta H. Okay, this is the same as that of the reversible. This value will get, irreversible also this value we get, and also in free expansion also this value we get. That is why in my note it is not written, both in all the three cases it is same. All the three cases it is the same. So only one way I write. So in the reversible, irreversible and free expansion, all cases it is same. So this is all about the van der Waals gas. Now we have to discuss about the ideal gas. This is that means isothermal, reversible, expansion of van der Waals gas already over. Isothermal, irreversible, expansion of van der Waals gas it is also over. Isothermal, expansion, free expansion of van der Waals gas it is also over. Three factors are over. Now we will come across the ideal gas. Same process, isothermal, reversible, expansion of ideal gas. Instead of van der Waals gas, we take the ideal gas. This is the only difference. About all other things are same. Instead of van der Waals gas, we take the ideal gas. And all other things are remain same. In this case, isothermal means temperature constant, reversible means maximum work performed, expansion means lower volume to higher volume, and ideal means there is no force of attraction between the gas molecules, and the volume occupied by the gas molecules are negligible as compared to the total volume occupied by the gas. These are the two such more distinctions. Okay, expression for W, work done. Expression for W. ही तो कहीं आइलु जा लो कहीं आसचु रे सबु खाइलु पुणी आसचु कहीं जा जा ता पड़ा तो सबु मोर खाई साइलुनी मु कौन खाइबे लॉकडाउन समय तू कुआड आसचु कहीं आसचु जा कहीं तो जा हाँ जा लो हेक मु मारी आसचि लो हेक जा तो ऑटोमेटिक थी ऑटोमेटिक रिकॉर्डिंग ही न थी ऑटोमेटिक हाउ स्टार्ट expression for W. Expression for W means work done. Work is equal to force into distance. We know that work is equal to force into distance. This is the work done. We have to calculate. That means suppose this is my notebook. Suppose we have to apply force, external force we apply. Then what happens? Some distance is covered by this notebook. That means whatever the force we apply and whatever the distance it covered, that is we multiply, then we get the work done. So this is the work done. So that means my work done is equal to F means force, dx means distance covered. Then we know that pressure is equal to force per unit area. Then pressure into area is equal to force. Then pressure into area is equal to force. Now put this value of force here. We get W is equal to pressure into area into dx. Area into dx is nothing but volume. W is equal to P dV. It is expansion. That means work done by the system. That means energy of the system decreases. So we put here minus sign. So this is the work done due to expansion. Like the work done by the system. Work done by the system. By expansion, it undergo expansion. Whatever you can take, work done by the system or expansion, that is why I put here negative sign. So in that cases, that is the negative work done by formula. From the ideal gas equation, we know from ideal gas equation, from ideal gas equation, it is known PV is equal to nRT. PV is equal to nRT. Then P is equal to nRT by V. Now substitute this P value in this equation. When we substitute this P value in this equation, what we get? Now W is equal to minus, instead in place of P I write this one, nRT by V dV. This is my work done. Then whatever na, then we have to integrate this equation. We have to integrate this equation. That means nRT we can write also W is equal to minus nRT dV by V, because n constant, R constant, T constant. Then we have to integrate this one, integrating the above equation, integrating the above equation. V1 initial volume to V2 final volume, initial volume to final volume, we have to integration. Then we have to make integration. Then when you put integration, W is equal to, then W is equal to minus nRT, integrate V1 to V2, dV by V, dV by V, dV by V. Now nRT is constant, so that is why it comes outside. Dx by x integration is equal to ln x. Dx by x integration is equal to ln x. So this equation will becomes W is equal to minus nRT ln V. Limit is V1 to V2. First upper limit, then lower limit. So W is equal to minus nRT bracket ln V2, first upper limit, ln V2 minus ln V1. Then ln x minus ln y is equal to ln x by y. So W is equal to minus nRT ln V2 by V1, and final volume by initial volume. This is the work done in case of ideal gas, free expansion, reversible work done. But ln means base C, very difficult to get because base C value is 2.71. So ln means E value is 2.71, very difficult to calculate something to 2.71 of something power of 2.71, very difficult to get. In this way we have to make it natural logarithm. That means W is equal to minus nRT. When ln converted, it is becomes 2.303 log V2 by V1. So more popularly we can write like this. When we rearrange this, minus 2.303 nRT log V2 divided by V1. So this is the work done. This is the work done by the system. This is the reversible work done. This is the reversible work done by the system. In ideal gas. If you take in the system ideal gas, then this is the work done by reversible process. So now you have, suppose volume is not given, then how you change this volume? Now it is known that P1 V1 is equal to P2 V2, Boyle's law. Using the Boyle's law, I can know that P1 V1 is equal to P2 V2. Then take V2 to this side, P1 to this side. Then V2 by V1 is equal to P1 by P2. So instead of V2 by V1, I can put P1 by P2. So in this place of V2 by V1, I can write P1 by P2. Suppose volume is not given, pressure is given, then you put this value. Then your work done formula is minus 2.303 nRT log P1 by P2. This is the work done, reversible process in terms of pressure. If volume is not given, then you can put this value. But remember, the next is, let us remember that in ideal gas is a function of temperature. With ideal gas, the ideal gas, the internal energy, can call that the internal energy, the internal energy of an ideal gas is a function of temperature. That means TMPRAT. Temperature, that means internal energy U is a function of temperature. If dT is equal to 0, then delta U also equal to 0. So if that means change in internal energy is equal to 0 when temperature is change in temperature is equal to 0. That is why it is called internal energy of an ideal gas is a function of temperature. If temperature tends towards 0, internal energy also tends towards 0. It is only possible, remember, in case of ideal gas. It is not possible in van der Waals gas. So it is only possible in case of ideal gas. Then we have to do some graphical representation of the work done. Graphical representation. In case of first we write PV diagram. PV diagram. In PV diagram, if this is the pressure, this is the volume. So volume is in the x-axis and pressure is in the y-axis. This is the y-axis and this is the x-axis. Then what is the work done carried out? Now in case of expansion, the gas tends like this. And what is the work done? Now this is my work done. That means this one is initial volume V1, final volume V2. Arrows tends towards like this because it is expansion. It is expansion. That means work done by the system. Expansion means initial volume V1. Suppose 0, 1, 2, 3 liter, 4 liter, 5 liter, 6 liter, 7 liter, 8 liter, 9 liter, 10 liter, 11 liter. That means from 2 liter to 10 liter it is expand. That is why this arrow sign tends towards final volume. So this is the expansion. And what is the work done? Now work done formula is minus 2.303 nRT log V2 by V1, final volume by initial volume. And this is the expansion. What is the area of work done? And this is the area. This is the area of the work done. This is the area of the work, complete area. Okay, this is the area of the work done in pressure volume expansion. But in case of compression, when you compress the gas, this is the pressure axis, this is the volume axis, this one is the x, this one is the y. Same process, but in case of compression, same area, but compression case, it compressed from final to lower, higher volume to lower volume. So now it was from V2, it was V1, and this is the work. In case of compression, whole total work inside the curve, but arrow is V2 to V1. Then in this case it is only compression. In this case initial volume is V2. In this case initial volume is V2, final volume is V1. Because higher volume you have to compress it to lower volume. That means suppose this is my system, this is the piston, this is my V2, this is the initial volume. Now we apply pressure. This piston comes downward and now the piston comes here. The piston comes here and this is the V1. So that means from higher volume to lower volume it was compressed. That means higher volume is initial, this is the final. So your work done becomes W is equal to, here only you have to change this one. Here will be compression, work done on the system. Work done is positive. So it is the positive sign. 2.303 nRT log final volume by initial volume, V1 by V2. In this case final volume is V1, initial volume is V2, and otherwise if you do not know compression, if you change V1 to V2 by V1 to V1 by V2, it automatically comes positive. So this is the compression case. This is all cases are all the cases are reversible. This is all cases are reversible. But in case of irreversible, less work we have. When we study the irreversible cases, I will tell you how less work is performed in irreversible process. And reversible process, maximum work is possible. But irreversible process, minimum work is possible. So this is the PV diagram of the graphical representation of the PV diagram. The other diagram is also possible. Suppose second is pressure temperature diagram. PT diagram. When pressure temperature diagram means, suppose here is the pressure, here is the temperature, this is the x-axis, this is the y-axis. Here temperature remain constant. That means isothermal process, temperature will not change. So that means a particular temperature, pressure will change. This is the pressure temperature diagram. But temperature is constant. When temperature is constant, when the pressure increases, pressure decreases. That means this one. Temperature is constant. Temperature is constant, only pressure will change from P1 to P2. That means suppose it is initial pressure P1, this is the final pressure P2. But this is that means when in case of expansion, that means mistake. That means when the pressure this is the pressure increases, to the y-axis pressure increases. When suppose this is my initial pressure P1. Okay, when the initial pressure means very high pressure, 5 atmosphere. That means when you compress it, that means this is the initial pressure, suppose 5 atmosphere. When you pressure decrease, it will come to the pressure 1 atmosphere. That means pressure decreases. When pressure decreases means automatically volume increases. So this 5 atmospheric pressure is initial pressure, it is the final pressure. Then in case of expansion, 5 atmosphere pressure to 1 atmospheric pressure. That means when pressure decreases, volume considerably increases, because both are inversely proportional according to the Boyle's law. So pressure 5 atmosphere, it is initial, it is final. So final means always we consider final by initial. So in that cases you have to put the value P1 by P2. This is the P1, this is the P2. When you change always final by P2 by P1, it will come negative. Expansion becomes negative. Okay, similarly, when you, in case of compression, this is the temperature, this is the pressure. In the y-axis, this is the x-axis. Temperature is constant. But here 1 atmospheric pressure to increase to 5 atmospheric pressure. When pressure increases, volume automatically decreases. and this is case happen in case of compression. Okay, in this way you can pressure temperature diagram. Similarly also volume temperature diagram also you can carry out. Volume temperature diagram. In volume temperature same process. Here is the, that means x axis, this is in the y axis, and this is the volume, and this is the temperature. Then temperature is constant. Volume increases or decreases. Initial volume to final volume, or final volume to initial volume. V1, suppose it is initial volume 1 liter, this is the final volume 5 liter. That means volume will expand. So final volume by initial volume. Similarly, this is in case of expansion. That expansion means volume from 1 liter to increases to 5 liter. Similarly, in case of compression, what happens? Now this is the temperature, this is the volume, this is the x-axis, this is the y-axis. Constant temperature. From initial volume is 5 liter. It was compressed to 1 liter. This is in case of compression. Always final volume by initial volume 1 by 5. So it will come in that compression cases positive because work done on the system, expansion cases work done by the system. So in this way you can draw this diagram, pressure volume diagram. This is the reversible work under the cases. This is the constant temperature, both cases are constant temperature, and pressure volume and volume diagram. Then next one is internal energy. In expression for internal energy. Expression for U. I already told you that internal energy of an ideal gas, internal energy is a function of ढाली देला रे कौन कहब ये मूषा तो ग्याप न मारी दी तो मुंडटा दिगड़ा आज करदेवी रह गोटे मिनट रह मुझे तो देखी ते इंटरनल एनर्जी इज ए स्टार्ट इंटरनल एनर्जी इज ए फंक्शन ऑफ टेम्परेचर दैट मीन्स यू इज ए फंक्शन ऑफ टेम्परेचर दैट मीन्स व्हेन dt is equal to 0 change in internal energy also 0. That means change in internal energy 0 at dt is equal to 0. As dt is equal to 0, internal energy also change in internal energy also 0. This is the expression for U. Today we end here because okay. Thank you. पढ़ापढ़ी सब आराम रे कर जमा बाहर बुलबनी बाहर तुम जाच गवर्नमेंट तो छाड़ी बाघ सबुआड़े कहीं बढ़ी जाऊँगी कोरोना सबुआड़े सुंदरगढ़ आरंभ कर झारसुगुड़ा देवगढ़ बलांगीर सबुआड़े कोरोना बाहर तेणु कंट्रोल करने गवर्नमेंट कौन कर 300 ରୁ 400 बाघ आ सिंह मिसिकी सब गाँव में छाड़ी तेणु से बाघ सिंह माने सबु गाँव में 3-4 जन ही सब बुलूं से आज 5-6 दिन है खाई ना बहुत भूका अच्छा तेणु तुम बाहर बुलिले से धरी पलैबे तुमको तेणु बहुत केयरफुल जमा टीवी भी देखनी कारण बेले बेले बाघ आ सिंह घर भितर पशि जाती जदि से देखो जे तुम पढ़ुन टीवी देखुच ताहले से तुमको धरी पलैब खाईदेव ताक भोक लगुच 4-5 दिन है से खाई ना तेणु तुम जदि पाठ पढ़ुव टीवी देखनी कि बाहर बुलबनी पाठ पढ़ले बाघ देख तुमको छाड़ी पलैब कारण पाठ पढ़िया पिला से खाइनी तेणु पाठ पढ़ले तुमको से छाड़ी पलैब तेणु सबू गाँव में बाघ भालू ना बाघ सिंह बुलूं तेणु तुम जमा बुलबनी पाठ पढ़ एगुड़ा बारंबार प्राक्ट प्राक्ट न कले हेनी ओके ये मूषा ते मारिदेवी आज ते मारिदेवी तोर मुंड आज काटी मारिया तो खाई पशि जाऊँगी अरे ये बंद कर काली भी से